I'm excited to present Shapemaker to all of you, and I'm hoping for an interactive session. So feel free to ask questions. There's a chat in the Google Meet meeting. You can write any question you like. There's also emojis, so feel free to also use those for reactions. With me today, I have a few of the team members from Shapemaker. I got Vladimir, PhD and principal civil engineer. He'll be part of the presentation. I have Andrei, who's a senior civil engineer who will be answering questions and helping. I also got Sindre, our CTO, who will be in the background helping with any technical questions or problems at your end. And then finally, I got Ingrid with us, our CEO. Do you want to kick off, Ingrid, with just saying a few words and introducing yourself?
Yes, so hi everyone and welcome to this webinar. I'm super excited to see all of you. 2025 has been a great year for us. We have got new clients, launched new features, and also entered new markets. I'm also super excited about 2026. A few examples of what's coming next is, of course, launching a TIA standard that will open up new markets for us. We will also support rooftop structures, and we are also launching a completely new Shapemaker toolbox. So please stay excited about what's coming next. And I also encourage everyone to follow us on LinkedIn and sign up for our newsletter to be kept updated on our latest news. That was all for me, and yeah, I will hand the word over and the show over to you, Jonas.
Thank you, Ingrid. So again, welcome all. This webinar will be 3 parts. In the first part, we'll go through some of the high-level use cases and workflows in Shapemaker. This will be interesting for all of you, but specifically for those of you that deal with the daily operation of tower infrastructure. Next, the second part, which is the main topic of this webinar. In the second part, we will go through the full workflow of modeling a tower in Shapemaker. We'll create the tower, we'll add equipment, we'll analyze it, look at the results, and a lot more. Now, in the second part, I encourage all of you to be interactive, ask questions. All of you should have received sign-up information or sign-in information to Shapemaker. So you have the option of following along in your own workspace as we go. And if you have any issues with that, feel free to just reach out in the chat. Either way, after the webinar, you'll also still have access to your Shapemaker account for a limited time, so feel free to just try out afterwards as well. So let's jump into part number 1, high-level use cases of Shapemaker. So Shapemaker is a structural analysis and tower data platform. We're a cloud-based platform where you can keep all of your tower data and equipment centralized, accessible for all. The main feature and value proposition of Shapemaker is that we automate structural analysis, which enables you to faster and more easily run calculations. We have 2 main customers. The first one are Towercos, typically Towercos who wish to gain control of their data, their structural data, and who wish to streamline structural analysis, maybe collect all of their contractors in one platform. And the second customer we have is engineering consultancies who wish to work faster, automate more of their processes, and achieve less errors. So I want to go through a couple of use cases at Shapemaker. So let's have a look at Shapemaker. Opening up app.shapemaker.io, you get an overview of all of your sites in the portfolio. Starting off, we see that we have 64 sites in this demo account that I'm in right now. We can open the map view where we start to get an overview of all of our sites. We see a lot of green sites. Green sites are underloaded sites, so these are sites that could potentially hold more equipment. Red sites are overloaded sites, which might need to be either reinforced or replaced at some point. So one of the most common use cases with Shapemaker is to do co-location. So typically a Towerco would have a lot of towers with additional space on them, and you would have an operator, a mobile network operator, requesting to add equipment to a specific site. So let's just, for example, click on this site right here. It's green, we know that it's underloaded, and let's imagine that an operator wants to put 5G equipment on this site. I'll go to the site. As I open the site, I get a feeling for what this is. I can see what tower family it is. It's an SMK. I can open the side view here, and I can see what equipment is already on the tower. I see that we have 3 tenants on it already. We have O2, Telenor, and Vodafone. I can quite quickly tell that there's a lot of vertical space on this tower, so I know that we could easily fit at least one more tenant in this open space in the middle here. I can go further and go to the results tab and see what was the latest analysis performed for this site. I see summary here, it's underloaded. I can see when it was performed, this analysis, who performed it, why it was performed. I can see some main results. I can see that it has 95% utilization of the leg, so there's not a lot of capacity on this tower right here, but I see that it's underloaded, so it's worth to try to add some equipment to it. So let's go to the ancillary tab and let's play out this co-location request. So in this tab, we'll add some of the equipment that the operator wants to co-locate with. So let's add a few GSM antennas. I'll just search GSM and I'll select this Catherine 742237, for example. And let's go ahead and add, let's say that we want to try to put them at the height of 22 meters. Seems like there's space for that. Let's go ahead and add 3 of these GSM antennas, 1 for each face of the tower. Now you see we have these 3 panel antennas, and let's go ahead and say that it's Telia who's making this co-location request. And at the same time, we could also go ahead and set this as planned, so that we have control of which the equipment is actually on the site and which we are testing out. Let's also add some RUs. Let's just imagine that there will be also 3 RUs, 1 directly behind each of the panel antennas. So I'll set this to Telia. I'll set them at 22 meters, also on each face. And there we go. And finally, I'll also set all of them to be planned. And there we go. So now we have a new tenant on this tower. We have Telia. I can highlight it right there. We see that it's located at this 22-meter elevation. So now let's go ahead to the results page and press run analysis. So at this point, we are performing the full structure analysis, considering all of the load cases, load combination, checking the capacity of all of the legs, the bolts, the foundation, if there's any foundation specified, which is not in this case. We're considering all of the antennas, the feeders, etc. Now we got a result back. Unfortunately, it's overloaded. So at this point, we wouldn't be able to co-locate with this equipment configuration. It's at 109%, so not that high. We could consider reducing it a bit. Let's try to just move all of the antennas down to, let's say, 18 meters, and see if it holds in that case. And then finally, I'll also enable automatic shielding, which will take into consideration that when the wind is approaching from this angle right here, this GSM antenna would cover the RU, leading to less wind impact on the RU. I'll do that. I'll press run analysis again, and then we'll see whether we get a better result. And yes, actually we did. So now we got it at 96%, 93.3%. At this point, we can go ahead and say to Telia that in analysis, this is all right, we could co-locate. So that's one of the use cases of Shapemaker, very fast being able to answer co-location requests. And now we also have the report. I'll really quickly download it and just show it to you. And that report can then be used to, actually I'll show the report later. Let's leave it for now. That was one of the high-level use cases of Shapemaker. Let's have a look at another one. So when you have parts or your whole portfolio in Shapemaker, you can start looking at the portfolio as one item to optimize. So we can head over to the Insights tab at the top right corner. We can see immediately which sites are underloaded, overloaded. We can see which tenants we have. We get a feeling for the utilization distribution. And the utilization distribution, you really want to have all of your towers in the 80 to 100% utilization, meaning that you're utilizing your portfolio in a good manner. We could also have a look at, let's say that we want to start introducing a strengthening scheme for one of our tower families. So now I just select this SMK tower family. And here we can see we have 6 towers that are overloaded. We could go and go over to, sorry, let's select utilization to be 100 and more. And in that way, we can have a look at only the overutilized towers. And at this point, we could kind of dig deeper into it, see how we could strengthen this to apply to the whole, apply the same strengthening kit to all of the towers. We could plan strengthening. We could plan annual replacement schemas, etc. So that was the high-level overview of Shapemaker. And now I want to move over to the main part of this webinar, which is to go through how to model and analyze towers in Shapemaker. So I am guessing that a few of you guys, you are now thinking, how do I get the data into Shapemaker? Because now I just showed you an example of how fast you can answer a co-location request and what insights you can get when you have your data in Shapemaker. So getting data into Shapemaker can be performed either if you have already structured data in a database, say you have equipment, antenna equipment, you have site name, site information like height, or a tower family name, we can use that information to automatically populate your portfolio. So that's the case if you're a Towerco and you have some structured data. If you're an engineering consultancy, we see that a lot of engineering firms already have a lot of their previous analyses in MS Tower, Global, Open Tower, another tower software, or in Excel sheets. For those type of data, we can easily automatically onboard the tower data with all of the equipment directly into Shapemaker, so you can already start working off from the data you already have. And finally, since Shapemaker is API-based, we can integrate with any software or platforms that can use our API, which is most of them or all of them. And then finally, if you don't have any data at all that you wish to start off with, you can do what some of our clients are doing, which is to go step by step and add towers and sites when you have a co-location request. And how you do that is exactly what we will do now when we go through the workflow for modeling and analyzing towers in Shapemaker. So to start off with, what you want to do is to add your tower drawings to Shapemaker. Typically, you often have the tower family in the system. I'll just give an example. We see that for Towercos with about 1,000 sites, they often have between like 5 and 20 tower families, and then some variations of strengthening. And to onboard a tower drawing, we'll head over to the tower builder. And in this part of the demonstration, I'll ask Vladimir, who's one of the brains and architects behind this feature, to go through how to add a lattice drawing. So Vladimir, if you would like to take over the screen, let's see.
Yes, Jonas, thank you for allowing me to show everyone what Tower Builder is and how it can flexibly allow inputting any type of tower. So what Jonas shown so far is regarding the structure itself. That when you create site, the site works with the concept of families, and the families are towers that share the same geometry, and they are divided into defined sections, which allows certain flexibility that you can of course create from the same family a shorter tower or a longer tower. I'm going to show you how you can create this from scratch, and in just like 5 to 10 minutes, you will be able to use that tower in structural analysis on real site, adding if you add ancillaries such as Jonas shown. And I encourage you to, if you have your accounts and if you are logged in, you can follow my steps to see how it really feels. So what I need to do is I want to create a new structure family. I will call it, for this example, descriptive like 4 legs K tower. I am the one manufacturing it, or you can add any description or manufacturing here. And I'm going to create a lattice tower. Currently, we support creation of lattice towers and monopoles, so you can create either of them. And I will add the structure family. At this time, I need to add designs. And the design can mean a single section is a design, or having a 40-meter tower configuration is a design. And I can combine those. So if I create one design for 40-meter variant of the tower, and later you would like to add maybe a bottommost section that would make it 45 meters, you can easily do that by adding a new design. So I'm starting with the design, and I will specify the number of legs to 4. And now the next step is to specify tower outline, which is basically the overall dimensions. So let's make a 40-meter tower with bottom width, let's say 4 meters, and a top width 1 meter. The viewer on the right side will show you any progress that you are making, and you will see that, of course, now we have just the outline, but more data is, of course, going to be shown there. Now my outline is has a constant tapering, and for my tower, maybe I don't want that. So I want to add an elevation where at 35 meter, the width would be 1 meter. So from that elevation upward, my tower is constant. I'm seeing here that error that sum of all the sections heights is not matching the tower height. Of course, I have no sections yet. Let me add those. And the sections are basically built from the bottom. So I need to specify a name and its height, and I need to specify what panel geometry I want to use. There is about 50 or 40 or 50 different topologies that I can choose. So if you want to have a look at all of them, you can click on this button. You can also filter by searching by name. For this tower, I will use the K1 hip-braced panel. And now I am able to specify how many of these panels are in that section. So it's just 1 or 2. Typically, the height is both panels in that section would share the same value, but it is you can overwrite this value. So for my first section, I will just use single repetition. And now I defined one section. The other sections I usually define very simply by not just creating a new one, by copying and editing. So I need to change the name, and I need to change, in this case, I want to have, let's say, 2 K panels as the second section. My third section, I want to have quite the same. So of course, the geometry typically is quite repetitive. So copying the section makes big sense. So now I created some K panel configurations, and now my tower gets to the narrower side elevation. So I will create some DL and DR pattern, and I can actually just apply the DL. Of course, that's not, you can see that that's just one panel, but here I can add really a pattern like DL, DR, and this will repeat the geometry, for example, twice. And you can see that the entire geometry, and it doesn't matter if you have maybe even 8 panels, it's just created in the same manner. I will keep this back to 2, and again I will go on and copy this, change the name, and maybe for simplicity I will just copy this one more time, and here on the topmost level I will add little, like, one more repetition. And this is a demo tower that I wanted to show you. Now let me get back to the first section and the first panel, because I can imagine that you can have other shapes of panels than we currently support. And Shapemaker allows you all this flexibility to really draw your panel type. So let me just draw some panel with a quite specific geometry. You can see that I'm able to create different objects. I also see like the 3D representation. 3D representation is important because you can have odd and even faces, maybe slightly different. And I am able to, for example, add some redundant members here. And you can see that it really takes like, yeah, maybe 20 seconds to create a panel like this. And of course, now such long diagonal would be normally hip braced. For the simplicity of use in this, we instead of actually really modeling the hip bracing members, which is something that we plan, but for now you can actually use something slightly different, and that's just specifying that maybe in thirds of the diagonal length there are hip bracing members, and these in the structural analysis act as an out-of-plane buckling support, and I can just simply add those. I can name this panel K3 braced, for example. I can pick any name, of course, and I can save this panel, and by default it's already used. In the viewer, you can see that we also highlight these out of plane or in plane supports. Those are additional supports. We normally would get all the correct position of the out of plane and in plane buckling supports from the geometry, but if there is something additional, maybe some strengthening kit or something like that, this gives all the flexibility that you should need. For the continuing, let me revert back to the original panel. Maybe one more highlight is that you can see that whatever panel you create, you have available, and you can also create as many different shapes as you need very quickly. So now we edit panels. Let me add some plan bracings, because these K panel types would require some hip bracing. Let me pick this shape, and here I have only elevations that are that have applicable position for the hip bracing. It's of course the top of the K. So you can see that I'm quickly copying and editing the values, and that's basically all that I need to do. And this way I can assign a plan bracing pattern to any K panel to properly triangulate it. So when my design of the shape is complete, I can move to specifying the members, and here I specify the material and cross sections. There are different member types, and you can always see what you are editing if you just put your cursor over a specific group. You will see in blue highlight in the drawing what members we actually edit. And here I can, if I know that the correct way how my cross section is named, I can just write it directly here. If you don't, you can actually go to cross section selector, and you can pick any cross section here. You can actually also create, for strengthening applications, a combined cross section. So let me just allow you to create, let's imagine that this was a tubular member, and I wanted to strengthen it by adding a circular member. So here, the outer diameter, let me just pick, maybe for simplicity, I will just use rod, because that's just one item that I need to input, and to that I would add an angular member 80/80 and with thickness 8. And this way I added a strengthened section, and I need to specify elevations where this should be applied. So I don't specify the cross-section per panel or per FIA member. I just say that this cross-section is applicable between elevation 0 and elevation 10, and that's basically all I need to do. For the higher section, I will just use the 80. For, let's say, 2 more sections from 10 to 20, the 70 from, maybe just 240, like for the rest of the tower, I will use this one, so I can move quicker. For diagonals, I will just do something extremely simple. This is not realistic maybe for the K panels, but for me to be able to move further in this demo, you can of course imagine that we support rod, circular hollow cross sections, rectangular hollow cross sections, angular cross sections, and quite a few combinations of those, including combining multiple angular members into star or back-to-back shape. So here I will just very simply specify all the mandatory data. Of course, we are running structured analysis, so you can't have elements that have no material or no cross-section. So I will just very quickly specify it for all the structural member types, and I just specify a single cross-section for the entire tower. In reality, you can do as many divisions as your design requires. And now all my members, and you can also see that everything is just rendered with thickness, including the plane bracing. So now I can continue. Next item on the menu, let's say, is the design of or specification of the connections, because of course in Shapemaker we check not only the structural members but connections as well. So let me just pick a grade 8.8, and I can specify my connections. And in Shapemaker, even though I just said that we check the connections, if you don't have that information, they are optional. If you can fill them later, you can edit the design when you have more detailed drawings, but you can still create a tower. This tower that I have here now would be already publishable and usable, but let me just show you how I would define a single tension connection for the leg. Let's say that there is 4 bolts, diameter 24, and this connection is used for sections between 0 and 10 meters. Of course, this is not enough to really specify the connection, so more data is needed. I will specify some thickness. I can choose different shapes of the end plate with weld thickness. Let's say 4. The leg diameter is in this case was, I think, 90. Radius bolt line maybe, let's pick 70, and 30 as a value. And this way I defined a connection for the leg. I can of course define different connections for different elevations, and for example diagonal, I can specify that there is 1 diameter 16 bolt all the way to the top. And in this case, if I don't specify more details, the default values are going to be used. Now, one last thing before I publish is additional data. In our application, we sum the we use the value of computed mass, but sometimes you can have something additional. You can have some strengthening kits. You can easily overwrite it by adding, for example, one ton, and you can also overwrite that, saying that you can imagine that there are some fasteners, something that is extra projected area, and you can think that it's, for example, 0.1 square meter per panel that's going to be applied to the tower. So this is the flexibility of adding, really making sure that your model is exact as you need it. And now I can publish this design. You can here see that my design is published, but I can also, as I said, create a new one where I can specify an extra section. I will not do that now, but I will just show you that you can just now go to the list of all your sites, and this tower that I've just created, I can open it and I can use it. I can open the window so that you can just see how the tower looks. And now I just slide all these items in here. Of course, I will do this only once, but now I can save this as a template. I will call it 40 meter. So now whenever I would like, and I can save multiple templates, maybe for 25, 30 meter tower. So the next time I would like to load the tower full height, I will not slide every panel there one by one, but I will use the template. So this is what I wanted to show you, that Shapemaker allows you to fully flexibly create any panel shape you can have, apart from those that we already have prepared for your convenience in our system. And you can, from using these panels, these basic blocks, you can build a tower with various cross sections, applying strengthening kits, and now it's the workflow back to what Jonas shown and what he is going to show you further.
Perfect, Vladimir. Thank you very much for presenting that. And I'll continue off where Vladimir left. So now we have created a site with this 4 legs K that Vladimir created. I'll just go ahead and rename it to site 5, for example. And as Vladimir showed you, you can configure this tower in any way you want based on the sections. And of course, you could also make it very high. Not saying that it would make sense with this panel type, but whatever configuration you want, which is possible, you can do. So let's go ahead and keep it as the original 40 meter version. Now we can move on to the next step, which is to specify the foundation. I'll open the foundation tab right here. I'll select that we should analyze foundation. Now in the real world, where you have a site that you want to analyze, you would specify it correctly. But for now, I'll just select one of these foundation templates and be happy with it. Now, if you're curious about what checks you are performing, especially with foundation, but also with everything else, you could go to this help button in the top right corner, and you see that it tells you that you can either chat with us, which is this bubble in the bottom right corner. Here, when you send a message, there's no bot, there's no AI. The message is gets sent directly to our civil engineers and our software developers, and we use that to help you out with any issues. And we also use that for product prioritization and defining what to do next week. But I also wanted to show you that you can press it and then you can read the documentation. Now I just open it. It's at docs.shapemaker.io. And you could, there's a lot of good information there, but you could have a look at which design checks Shapemaker does. And we can see that for foundation, we do overturning, burying, and foundation sliding. So let's move back again to Shapemaker. So we see that we have this foundation right here. This tower, it's looking all right. I'm happy with it. We also have maintenance. So if you haven't correctly torqued your flange connections, the prying effect will impact the results. So that's also an option. Let's move on to the next step, which is to specify the location. So location one of the main features, differentiating features of Shapemaker is that we automatically generate, automatically do a site-specific analysis. So in this case right here, let me just put it in a very nice location right here. I'll go ahead and automatically fetch the altitude. I'll just set the orientation to 45 degrees. I'll estimate the base elevation based on the foundation data, just pressing that. And then finally, I'll select the Norwegian national annex to Eurocode, as that's where we're in right now in Norway. I'll press automatic wind profile. And now in the background, we're fetching the fundamental basic wind velocity from the national annex. And for each of these wind directions that we have right here, and you could also edit them to add more or remove wind directions. For each of those wind directions, we would be estimating a terrain category as per Eurocode. In addition, we would be calculating the orography impact. We also have a very good article on that in our docs. It's called "How Do We Assess Site Parameters?" And it's right here, and you could have a look at that one if you're curious to go into the details. So let's have a look at this site right now. And then, sorry, I forgot to change where I'm sharing. There we go, you see the site right now. So we can have a look and see what we found in the automatic site-specific analysis. So we can press Edit Wind Profile to see what terrain category we found and which fundamental basic wind velocity we found. In addition, we can go deeper and have a look at the orography impact. So you see it's quite a interesting site, quite hilly, and has definitely some speed up effect. So in 0 direction, we're seeing that we found this crest, this base upwind, and this base downwind. And in this view right here, you could start to go through each of the wind direction and seeing if you agree with our automatic site-specific analysis. Of course, you can quite simply edit the base if you believe it should be something else, like this. Press apply, and you see that the orography impact would change. So now we have a site, we have a location, and we've done the site-specific analysis. We also have icing, which in Norway could be relevant. We perform it according to the German annex, and you simply specify glaze thickness and ice density. Perfect. So let's move on to the ancillaries. At this point, we want to start populating the tower with equipment. We have our ancillary database, which you can find in the database, which by default consists of a lot of generic ancillaries, but you can also add your own ancillaries, and we can have a look at that later if we like to. But let me add a few GSM antennas. So now let's see what happens. I'll just do like that. There we go. So we see that we have these GSM antennas, very, very thin GSM antennas, but that's fine. Let's add 4 of them, and let's add them to each of the faces. Like that, and let's just select O2 as the tenant. I'll quickly also add a few RUs. And in this part of the demo, I'll just do it a bit fast. But bear with me. Okay, there we go. And we have 90, 180, and 270. Now we're starting to see that we have some panel antennas right there. I'll just select the correct tenant here as well. Perfect. Starting to look good. For demo purposes, I'll just real quick also add another layer. So let's do it like that. Here we go, and I'll say that the second layer is Vodafone. Here we go. I'll set it to 38 meters and see if that works. hopefully it works. Nice. Oh, it was a bit too close. Excuse me. 36 then. Nice. And then as we're working, we see that the model is being updated. Perfect. That looks quite good. I'm happy with it. We have 2 tenants, 2 layers of panel antennas. Let's just add a mid-dish for fun. I'll add it to maybe at like 20 meters, and it will be Telefonica. That's fine. There we go. We have that tenant as well. And at this point, without analyzing, without doing anything more, you could go ahead and download these drawings. And this will be a drawing of, I just have to change what I'm sharing, just a second. So you can see the drawings that we just generated, and this is based on, of course, the tower family that Vladimir onboarded, and we also see all of the tenants, and we have a plan view for all of the layers of tenants. Nice. And then jumping back to the presentation, now we have equipment on board. I'm happy with that. So let's move to the next step, which would be to define the linear ancillaries. At this point, I'll make it a bit simple. I'll say that it's something like this. Go all the way to the top, and let's edit and see how that looks. There we go. And of course, you could also specify which legs to mount the antennas to, both linear ancillaries and the discrete ancillaries. Let's move to the model. We have equipment on it. We've defined the location. We've defined the foundation. It's looking really good. Let's go and press run analysis. So now in the background, we are finding all of the load cases, load combinations, calculating all of the capacity for all of the legs, all of the members, all of the connections, and the foundation. We are doing that for every wind direction that we included in the site-specific analysis. And here we go, we have some results. Let's look at it. So bracing members, 959% overloaded. Looking at just the model here, we see that they're really slim. So I don't think anybody would be surprised. We generate a report, and we can also see how the capacity and the forces are in this view right here. Now we just finished generating a report, but let's have a quick look at the FIA view as well, where you could get a look at which of the members are failing, and you can go deeper and look at specific load cases and load cases to see what loading we've considered. Now we generate the report. Let's go ahead and download it. And then I'll just quickly change what I'm sharing again. Just a second. And the report looks like this. Generated for the site, by whom, and at what time. We have an executive summary saying that at this moment, it cannot hold requested loading. We can see some high-level results. And we see that there's no rest capacity, no additional capacity in the tower. The report is very extensive. You can also find an example report on our website in the platform overview and also in our docs. We go through the site, the structure data, all of the ancillaries, shielding, equivalent static method criteria, all of the loading parameters, all of the load cases, the intermediate values for the capacity used in the design checks, deformation, finally foundation, and hold-on bolts. And at the end, we also describe what references we've used. Perfect. So now we've built the tower in Tower Builder, we've created a site, we've added equipment, we've done a site-specific analysis, we've done an analysis, we checked the report, and here you have it. That's the full workflow of analyzing a new tower in Shapemaker. So at this point of the webinar, we're happy to see any questions that you have. So feel free to just either use the in-app chat to write something to the team, or you can write something in the Google meeting. In the meantime, while we receive questions, I'll just show you our ancillary database. So I'll change what I'm presenting again, just a second. Now you see our ancillary database, and as I mentioned previously, here you could insert your own ancillaries. You could also set your own force coefficients, and you could even use manufacturer data to wind tunnel manufacturer data to get a even lower force coefficient. Cool. And feel free, Sindre, to just if there's any question, you can just read them out loud.
Yes, we received a question from Bashar here. So he asks, before conducting co-location or upgrading check, is there an option to save the current analysis results so we can compare the updated utilization ratio with the previous one or with the original tower design utilization ratio?
Okay, so the question is, how can you compare results between different variation or different results? Exactly. So as you see now, we have one result for this tower right here. If we were to go to the discrete ancillaries and say add automatic shielding, we also have a great article on how to do that in our docs, but now added automatic shielding. I'll rerun the analysis. I'll just take a second. And then we'll see the results. And also I see that we're getting a question in the chat. I don't know if Vladimir or Andre, if you would like to jump on that after I finish this one. So now we see that there is analysis finished. We can click on previous results. So here you can see the last analysis that we did. Here you have 107.8% capacity. In the new analysis with automatic shielding enabled, we have 7% less utilization. So that's a good jump. And here we could also see all of the old generated reports. So in this way, you could compare results. There's also the option of downloading a JSON for a result and a JSON for another result, and then do this using coding if you like. And then Vladimir or Andre, would you like to answer Richard? It's a question of whether our software performs dynamic analysis using damping ratios as input or from the codes.
Yes, I can maybe answer this. We take the values from the code, from the Euro code directly, so there is no way right now to input them manually.
Yes, so we automatically use the right values from the code is how I interpret the answer then.
Yes.
Thank you, Andre. And then there's a question from Ala Diab. Can we create our own sections for the components? I was wondering, Ala, if you could elaborate on that in terms of, I'm not sure if I'm misunderstanding, but I'm wondering whether these custom panels that Vladimir showed, if that is part of the answer, but feel free to elaborate, Ala, and then we will answer it. Rolf has a question of the roadmap for Shapemaker. Would you like to answer that one, Sindre?
Yes, I can try to answer that. We are a super fast-moving team, so the roadmap changes a lot. But what we know is that TIA and rooftops are coming very soon. Also, this custom geometry that Jonas showed recently, where you build your own panels, that's something we've been working on lately, and we'll keep improving that. And on top of that, we're doing some work on site specifics. For example, releasing an open version, a tool which will be more accessible to anyone outside Shapemaker as well. And then we always love to hear feedback from you guys. So we know, especially Ralph, we have gotten a lot of good feedback from you. So I think we'll just say that keep it coming, and we'll decide the roadmap further on from that.
Perfect. Thank you, Sindre. And I also want to mention that We have newsletters, as Ingrid mentioned, and if you go to our website and scroll to the bottom, you can sign up here. In addition, we have our blog, and we have a specific product updates. And here you can see updates that we've done just the last few weeks with improving tag management, more business insights, new drawing types, new annexes, etc. And these updates are also available. It's easy to see in the app, where you have this top right corner with product updates, where we describe where to find the new features and how to use them. There was also a question regarding future build standards. So TIA is in development, and we've gotten really far with it already. We're planning to release the TIA version early next year. And if you're keen to be notified about that one, you can go to shapemaker.io/TIA waitlist. I'll also just post that in the Slack, in the messages right now. So feel free to sign up there if TIA is of your interest. US or Canadian standard is also something that we've discussed implementing, and it's something that we will implement either based on market feedback or for a specific client or customer as part of commercial discussions. So there's a lot of questions here. Okay, Ala, there was another one. The cross-section of each element. Yes, okay. Ala, so Vladimir or Andre, would you like to answer Ala? So he just elaborated on saying that he's referring to the cross-section of elements. Would you like to take that one, Vladimir?
Yes, so in the current state, what we do in Tower Builder, that we check whether such a cross-section size is manufactured, and we offer, maybe Jonas, if you just start writing in the input field, just CHS, I don't know, H100, and you suddenly, when you write it something, you see manufactured cross-sections that are from international libraries. There is no way how to tag like your favorite ones that you use most frequently, but yeah, this is the way what we allow, just having cross sections that are real to input.
Yeah, and then of course, Ala, you could specify of these cross sections. You can specify with whichever sizes that you want, and we would also automatically show you what properties we're calculating. And if there's any section geometry that we're missing right here, it's also something that we just do on a weekly basis, adding new sections as per what our clients and the customers are requesting. So there was a question about second order analysis, patch analysis from Louis. So we do patch analysis for all guide masts. So I'm not sure we even mentioned it, but we do analyze guide masts, monopoles, hybrid combinations of them, and also rooftops. So for guide masts, we do patch analysis by default. For lattice towers, we do patch analysis when the criteria, so when the tapered sections top is below or within the tower, we do also patch loading. When it comes to the equivalent static method, if it's not met, we present the values of the equivalent static method criteria. But as far as we've seen in the industry, we haven't found what to call it, a good or agreed upon way of performing spectral analysis. But we are very keen to implement spectral analysis as soon as there's some way of doing it which people are happy with. Yes. Let's see what else. Mount analysis, that's a good question, Yuva. So in terms of mount analysis, that's also something that we are moving towards in terms of increasing our flexibility, of enabling you to create your own panel types, which in the future can also be your own mount types. So we're envisioning that in a similar version that you're creating panels here, you would be able to create mounts. At the moment, we're not analyzing the mount elements themselves unless they are manually onboarded by Shapemaker, the Shapemaker team for you, which is an option. There's a question about the Australian and New Zealand standard. So we have, I think, I don't know what percentage of completion our Australian standard is, but we do have a quite almost implemented version, but not fully implemented because at the end of the day, we are implementing based on customer feedback and where our next clients are. So for Australian standard, we can easily finish the implementation when there's commercial traction there. And then there's another question related to additional steelwork, head frames, delta frames, face frames, etc. So as I mentioned, in terms of modeling the face frames and all of this additional steelwork, we're envisioning it to be done in a similar way as the custom panel. I believe you could somehow do it today already, but we're going to expand the support in that direction. We also, at the moment, we have ways to easily model it so that you include the weight and the effect on the wind easily. So we have ancillary types that are, for example, triangular head frames. And you can use this to include the loading due to the head frames, but we won't check the individual elements of the head frame in this version. But that's something that we're expanding into. So there's a question about API-based data ingestion. Are there any plans to support bi-directional integration with asset management or GIS platform so that utilization or reinforcement decision made in Shapemaker automatically propagate back into upstream systems? And yes, Ashish, you kind of hit the nail there. We're seeing that that's a workflow that we can easily enable and we want to enable, and we're already in the process of enabling. So we have integrated with one asset management system, and we are integrating with more systems. And the one that I'm referring to is Click on Site in this example. A question about second generation Eurocode. 100% yes. I think we're seeing that we've implemented already Eurocode, a lot of national annexes, half TIA and half Australian standards. We've already kind of made our system very flexible and easily expandable into new codes. So we will definitely be implementing the new Eurocode when that's released.
Metallic slab.
There's a question about adding a metallic slab on specific level of the tower. And in terms of, well, I think the answer is yes, but it depends on what you want to achieve with it. So we can easily model it so that it's included in the analysis, the weight and the load from it. But if it's an element that is to be calculated, but maybe you want to comment on it, Vladimir. So it's a question from Ala. Is there a possibility to add a metallic slab on specific levels of the tower?
Yeah, I would assume that without more context that when he needs to create like a working platform, and there is a specific ancillary type just for that, which is also, of course, you specify the weight, you see it in the rendering, and the via analysis and loading is transferred appropriately. So that's what we have in the moment to support the platforms.
Yes. So there's a question from Bashar regarding serviceability limits, weight twist deformation. Is there an option to let the software check the analysis results against those requirements instead of the codes ones? So the answer is yes. So you can both. I'll just go to my profile, select show advanced settings right here, And in the advanced settings, you can override reliability class, which via calculation mode to use. And you can also specify which partial factors to use for the SLS load combinations. This can be done on the site level, as we're seeing right here, and you can also specify whether to include natural frequency as a constraining check, as well as deformation and what levels to use for deformation. And then, of course, you can define it for the organization as well.
I think we missed one question from Haider earlier. He asked, is implementation of rime ice instead of glaze ice in the works? So I think I can answer it. And it's not really in the works, but I think what Jonas said earlier about kind of developing what we see the clients needing and wanting is something we'll prioritize. So if it turns out to be a big need for a client, then we'll build it.
Nice. And then it's a question about whether it's possible to integrate CAD with Shapemaker so that I can export detailed drawings from Shapemaker to AutoCAD. And the answer is that's no problem to implement at all, because all of our data, the way it's structured, we even have APIs that you could potentially do it yourself. At the moment, we haven't had any user requested, so we haven't implemented that feature, but also something that we're seeing that could really help the workflow between different systems. So yes, so I think it would be similar to how we today enable you to generate detailed technical drawings. You would then generate a CAD drawing. So there's a question about batch analysis and that sort of scenarios from Rolf, and I think that's a great question. So let me just show you real quick. So as a Towerco, or as somebody who just has a lot of tower data, could also be an engineering consultancy. Let's imagine that this antenna right here, for some reason, it's we want to update. So here we actually see that we have two versions of this antenna right here. We have one with radius 0 and one with radius 5 on the corners. So let's imagine that we wanted to change this one to also have 5 radius, and so I can't actually see my screen. This will affect one structure. That's not that many. Let's rather change this one to have 0 radius. Now what happened now? Sorry. Okay, that again. So yeah, let's imagine that this antenna right here, that it has some wrong information. Maybe the height is slightly off. So I can change it right here, and I cannot press save changes. You know why it's in there? Okay. Import it to that one right there. Yes, okay, so now I just selected this Catherine, the same antenna again. I'll just set the radius to 2 on this one. It says that I will impact 36 ancillaries. Let me just confirm that, and now I press save changes. So at this point, I just updated 36 sites with new antenna configuration. And that will greatly potentially impact a lot of the sites. So if we look at the map view right now, we see that actually a lot of the sites aren't analyzed anymore. So we can go ahead and press the Insight button. We can press Run Batch Analysis. We see that we have 41 analysis sites that aren't analyzed with up-to-date data. So I'll just press Run Batch Analysis right now. So what this is doing is that it's just taking all the sites that we have that can be analyzed, and we're just analyzing it as fast as we can. So I'll just press the status right here. I'll go to Batch, and we see that we already have completed 3 analyses since I pressed Run. And we're seeing that now these 2 sites are being analyzed. So as we go, we can go back to this view and see if we finish all of the 41 analysis within the next 4 or 5 minutes. Is it possible to import and convert MS Tower TD files? And yes is the answer. So I'll go ahead and move over to our test environment because this isn't a feature that anyone is using right now, but we did it. So I have to say, share another screen. Let's see. That's fine. Now I just went to my test environment, and we have the opportunity of importing from Arc, export from MS Tower, but we can also expand this into whatever format our clients wishes, and we also have done it for global export. And in the same similar manner, we can do it for other tower types, or sorry, other softwares. Let me just revert back, and then we'll see what else. Yes, there's a question about hybrid structures. Maybe I can stay here and still show you this. Can I show any of our hybrid structures, or are they not our? That's not our data. So the answer is yes, but I can't show you any of that because it's not. We haven't created our own hybrid types. It's our clients. So. But we do support hybrids in terms of any variation that you want, really. Monopole inside self-support tower. That version, what do you think about that one, Vladimir and Andrei? That's not the version that any of our clients have had, as far as I know, but do we support analyzing hybrid structures like monopoles inside self-supported tower? Vladimir or Andrei, can you answer?
I would answer as yes and no. It is possible, but there is a need for anyone who requires such a tower to have available to contact our engineering team, and we can make it happen. We do have several towers for a client of this design, and it works. It's the results are good, and the tower can be this way, or monopole can be strengthened this way. It's at this point just more laborious on our side, but it is possible. So get in touch with us if you have such a query. Yeah, so that's so it is possible.
There's a question from Ralph regarding segregating groups using tags and then running analysis for that specific tag. So I'll just quickly show you. We have a tagging system that you can use to group or cluster sites. And the question is whether we could batch analysis based on the tags. It's something that we've talked about, and but as far as I know, we haven't implemented it right now. But it's a very good use case, and it would be very easy to add. We can have a quick look at the batch analysis, how it's performing. It's been running for maybe 5 minutes now. So we see that it's 97% complete. It ran 36 of the towers have analyzed and succeeded, and 3 of them failed. And the failures is probably we could go to that site and have a look at it, but it's probably due to some misconfiguration of that tower. Cool. And then finally, I just want to mention that this is we just showed you the general workflow of Shapemaker. We did touch in on all of the main aspects of Shapemaker, but there's a lot of other features that we've added to simplify the workflow and make it even more efficient when you're getting into it. So I think we'll just wrap up right there, and we'll send out an email to all of the participants asking for feedback. We would really appreciate it if you could just give us some comments. All of you should have received access to Shapemaker, and you can try it out. And we would also like all of you to reach out if there's any questions, if you'd like a demo, if you would like to explore further what you could do with Shapemaker. So that's all for now, and thank you all for participating and for the session.